I am Charles Mayu, the product manager for SOLIDWORKS Electrical at Hawk Ridge Systems. So I am the one guy at Hawk Ridge that is in and out of this software daily. Spend majority of my time working with SOLIDWORKS Electrical, helping customers get up to speed with SOLIDWORKS Electrical and making sure everyone is working well with it. Just a little bit of background about myself. I am a mechanical designer by trade. School taught to use AutoCAD back in the 90s. Started using SolidWorks about 2000. So I've been a SolidWorks user for almost 18 years, almost 19 years now, and have worked in various positions at different companies, working from doing refrigerated display cases for supermarkets to mechanical or to medical devices to large industrial filtration systems. So I've had quite a different gamut of past experience before working with Hawk Ridge. I have been with Hawk Ridge Systems for 8 years, started out in technical support. So if you guys have been around a long time, you might have remembered me from technical support. Did PDM for a couple of years, and then when SolidWorks came out with SolidWorks Electrical, that's when I became SolidWorks Electrical specific for the last 6 years now. If you guys aren't aware of it, SolidWorks Electrical first came out back in August of 2012. So we're on our 6th year, 6th release of the software, and we'll go ahead and get into it here. So you guys haven't seen the ecosystem of SolidWorks, right? So we've got everything in there from data management to electrical design, all of that typical stuff, right? So we're going to be in these two realms here. This one is mostly PCB. We're going to be over on this one, which is working with wires, the interconnect of devices inside of your design. And today we're going to focus on is the schematic application, SolidWorks Electrical Schematic Professional. And we're going to do a comparison to the 2D traditional systems, right? So we're going to look at the current process with a 2D traditional drafting tool. In this case, we're going to use DraftSight. If you guys aren't familiar with DraftSight, DraftSight is the product that is created by SolidWorks' parent company, Dassault Systems. It is a direct replacement of a 2D drafting tool similar to AutoCAD or AutoCAD Lite. In fact, it has pretty much all the same functionalities as that product. So then we'll take a look at the faster schematic creation with fewer errors inside of SolidWorks Electrical Schematic Professional, easy data reuse and new content setup, and then we'll take a look at the final documentation at the end there. All right, so what's the most current process for most people, right? So a lot of times it's typically lines and text. You can speed it up using blocks or Lisp if you're using a traditional 2D drawing package. Very time consuming searching for symbols and or components. And then you've got to put the manual device tagging and wire numbering, and all of your reporting and air checking is manual, right? So I'm going to do one more poll really quick to see what you guys are currently using. So can you let me know what your current software you're using to design wire schematics with, whether it be AutoCAD, DraftSight, Visio, Altium, or something else? That would be awesome to let us know that. Okay, just to get an idea of what is out there, what people are currently using. So it looks like a good portion are using AutoCAD, right? So this might fit in with you now. When I'm talking about AutoCAD, I'm not talking about specific AutoCAD electrical. I'm talking about just straight regular AutoCAD. A lot of people do have AutoCAD electrical, but they don't have it set up. So a lot of times they are just using the straight regular AutoCAD. All right, so we got most everyone voted in there. So it looks like we're doing pretty good, pretty spread across everything. So let's go ahead and close that, and let's go ahead and show. Let's see. Let's go ahead and share those results really quick. So here's what the results that came in. So about 50% of the people said they're using AutoCAD. About 10% DraftSight, 10% Visio, 10% Altium, and 20% other. So that's kind of where we're at with that poll, which is kind of cool. All right, so let's going to touch base with this top 60% and a little bit with Visio, right? So kind of similar with Visio, kind of just drawing lines and throwing symbols down, really. So we'll go ahead and hide that poll for now. So instead of actually showing you guys how long it takes to do it inside of SolidWorks or inside of DraftSight, I have a little bit of video to show you guys, and this is a representation of what I'll be doing later, but what I have is a video that I recorded the other day of me using DraftSight, right? So I did speed this video up 10 times, and you can see that down here, but there is a little timer down here to show you guys what it is. So oh, sorry there, guys. I didn't realize when I played the video it was gonna mute myself. So I've been talking this whole time, not realizing I was muted. Uh, yeah, so this is a traditional thing I did using DraftSight. You guys can see it's roughly about 40 minutes for me to do a power schematic for the high voltage with clicking in and dropping everything in there and using just simple text. I did use some speed technology, techniques using existing blocks with attributes and fixing all those and inputting that information. But you can see it's a very manual process. I got to click on every single one of them, input the information for each one of them, move things around to clean it up, that type of stuff. Add in all the notes and text for all the wire numbers, manually update all that. Yeah, I could speed that up a little bit using Lisp routines if I was availability or if I had the ability to write Lisp routines for AutoCAD. And even inside of DraftSight here, filling out my title block, kind of the same thing, doing all that information that you normally would do. So getting up about 40 minutes here just for that same power schematic, right? So I've got everything in there. So now let's go ahead and jump back to my monitor, my screen here. And so you can see through that whole process, it took roughly about 40 minutes. I did speed up that video to about 10 times faster, so it only took about 4 minutes up of that. I didn't want you guys sit here and just watch me do that for 40 minutes. So that's kind of little things we did. And that was just to do this top two or top three inputs, right? The lines and text. I used blocks to speed it up a little bit. Time consuming, searching for symbols. I had to know my component information, right? So I had to go and think about which manufacturer's parts I wanted to use and know that ahead of time to fill out the the attributes on the symbols. All right, then manual device tagging and wire numbering. I had to manually track all my device tagging, manually do my wire numbering. And one thing I didn't even discuss was the reporting, right? And the error checking. So you think about that, that's all a manual process. I would have to open up Excel, type out everything in Excel to get my manual reports, right? So my bill of materials, all my wire labels, my wire lists, all that information, and double check, and then checking all that for errors is a very time consuming process. So say it took 4 hours to do our wire list, say another 2 hours to do our bill of materials, right? To get everything, make sure that's all right, because I'm doing it in another documentation software, Excel or Google Sheets or something like that. And then someone's got to go back and check all that for errors, right? So say 30 minutes to check errors. So you're looking at, just to do the power schematic, you're looking at 40 minutes, another 4 or 5 hours to do reports. You're looking at a full day, right? Full 8 hours to do a traditional drafting tool, to do that one drawing is kind of a general rule of kind of numbers thrown out there. All right. So let's look at the benefits of SOLIDWORKS Electrical, right? So we looked at the current process. Let's look at the faster schematic creation with fewer errors, right? So let's take a look at this. At this point, I'm going to go ahead and jump into SOLIDWORKS Electrical here so you guys can see what we're actually working on, right? So SOLIDWORKS Electrical Schematic is a application that does run outside of the SOLIDWORKS mechanical environment. So it is a separate application. It can run independently. It can be on the same license server if you guys need to do that, but it's a project-based philosophy, right? So as I open up my project manager, I see all my projects that I have here. Here's one of the ones that I'm currently working on, and I opened up and created a new template. In this template, I basically have my cover page. I've got my power schematic and my controls. So what I'm going to do is actually do a schematic real time for you guys to see, and you guys can see that within about 40 minutes, I'll have the exact same thing, but I'll have all my reports, I'll have my control drawing also, and I'll have all of my error checking done at the same time. So we'll start with our power page. That's what we're going to start out with. So we'll go ahead and expand that. Now, to draw my wires, I can come up and say draw multiple wires. Now, this is my multi-phase wire, right? So I'm going to go ahead and change out my wires. I'm going to use my 16 gauge colors here and draw that same bus down my left-hand side. Take care of that. And then go ahead and draw out my branch. Now, I don't have to do any copying or pasting. It automatically draws it out and gives me that availability of that information. Now I can start placing symbols. I'm going to come over to my left-hand pane over here, which I have symbols, and I've got a search tool here. So I can just type in, disco for my fuse disconnect. All right, so there's my 4-pole fuse disconnect that I'm going to use. I'm going to go ahead and double click on this. So if you guys saw in the 2D CAD package and draft site, I only had one orientation of this symbol. It was this one. I placed it, I rotated it, mirrored it, did all that. Well, while I'm doing this, I can actually do that real time with just a right click of the button. It will allow me to rotate this around and place this where I need to get it in the right orientation that shows the correct one. And right off the bat, it's going to do automatic tagging of this device for me. So 02F1, it's going to follow a formula that I have set up inside of my application or inside my project. That is to use my drawing number plus the root for that device, which is an F for fuse disconnect, and then the next number for that component, which is 1. I'll go ahead and click OK for now. And there's my F02F1. And then we'll come back over here. So we'll close that out. Come back over here and do a search. Now I'm going to do all my 3-pole. If I can spell pole correctly. There we go, 3-pole. So here's all my 3-pole devices. Here's my magnetothermal circuit breaker. I'll drag and drop that out and place that here. Once again, it gives me the next available tag for that, which happens to be 02Q1. Place that. Then our 3-pole fuse disconnect. We'll place that. Click OK. And then we'll get a motor over here. So we'll come in here and motor. If I go ahead and type in that location. We'll get that. Go ahead and find that. And here's our 3-pole, our 3-phase motor. We'll go ahead and drop that in. So M1, we'll get that placed in there. Now, what we can take a look at is the real-time design rule checking. right? So air checking. So I can do air checking on the fly while I'm doing my schematic design. So one of the things I'm going to check for right now is components missing manufacturer's part, right? So I just dropped in symbols on top of wires. And if you also notice that during I did that wire too, it automatically trimmed the wires out. So I'm not having to do that trim functionality. But here it's telling me I don't have a manufacturer's part assigned for all these components, right? So these components are also hyperlinked. So when I click on it in the report or in the design rule check, it brings up the device that it's associated to, right? So all those components don't have manufacturer's parts yet. So I'm going to go ahead and define that right now. Double click on our fuse 1 or F0, F1. We'll drop that in. So we'll go ahead and search right now. If you notice, it's got the circuit information down here. So it's looking for a fuse disconnect is what it's looking for, right? So I've got some generic parts here that I'm going to use, some by SWST, which happens just to be some SolidWorks stuff. So we'll go ahead and search for that. So there's my part. So I just searched by manufacturer. So you can build up your library, have all the components that you want, and it's searching based off classification. So it's only looking for the fuse disconnects, fuse disconnectors. And I highlight that. It automatically wants to connect that up and says, yes, I do have 4 fuse disconnector symbol or circuits in that manufacturer's part. We'll select that and drop that in there. And now that brings in all the other information for that component. The connection labels for the device, the manufacturer, the part number, the amp rating, and even the size. If I need to move things around, I can definitely do that by highlighting stuff, and I can move my symbol or move my attributes over to give my symbols a little bit more space here. So that way it's not sitting directly on top of my neutral or my ground wire there. I can define that. So we'll go ahead and get our fuse disconnect, or my circuit breaker, I should say. We'll search for that. Once again, we're going to use a SWST manufacturer search, and there's our circuit breaker. We'll assign that. And then our contactor relay, we'll search for that. Now, if I do my search in here for SWST, it's not going to find it. It's nothing. Reason being is I'm under a power contact, and this one actually is above it. It's just a contactor relay. It's not a power contact. So I have to go up to the same base class. If you notice, it also has relay coil and a normally open contact there. So we'll go ahead and add that and define that part also. And then over here is our motor. So we'll go ahead and search for that. And this one, we're going to use a specific manufacturer of Leroy Sumner. Oh, clicked on something early. And we're going to use an LS112. So I can put a portion of the part number in there, and it will search based off part number also. So I'll grab this 4P motor here, and we'll grab that and select that, click OK, and it brought in all of that additional information there for us. All right, so typically going between our contactor relay and our motor, we're not going to run direct wires out to it. We're going to put a terminal block in here and then run a cable out there. So I'll come up to my schematic tool, and we're going to go ahead and insert terminals. Now, if you didn't notice, it's very similar to SolidWorks or Microsoft Office, where we've got our command manager across the top, and it does have all the commands that we're using for the specific functionality, such as in my schematic, I'm going to insert terminals. I don't want to insert a single terminal, I want to insert multiples. So we'll say insert multiple terminals. I'll use a disconnectable, and I'm just going to draw a line across where I want my terminal to be. And this is going to give me a terminal strip of X1, and then individually number each terminal there for me. Okay, so we go back to our project settings and come back up to our design rule checks. Components missing parts is just our terminal strip. All right, so everything else got fixed on that. So we'll take a look at our terminal strip here. I'm going to go ahead and edit my terminal strip, which brings up a graphic editor of that terminal strip. Kind of gives me an idea what it looks like. I can see there's the 4 terminals within that terminal strip. And I can add a specific manufacturer part for these, for all of them at this point. I can come up, assign manufacturer part. In this particular case, I'm going to use a Wago. And it's going to be a 1201 search. We'll use that 2002 1201 right there. We'll add that, select that, assign it for all of those, and then we'll run our design rule check one more time. We have no components missing manufacturer's parts now. Okay. So at this point, I could do one of two things. I can go ahead and assign my cable that I'm going to use here. But in this particular case, I've want 3 more of these, right? So what I'm going to do is I want to create what's called a macro out of this. So this motor circuit I'm always going to use, but I may change the cable depending on how far that run goes. But I'm always going to use this circuit breaker, this contactor relay, this terminal with this motor, okay? So what I want to do is create a macro out of this, but I don't want to include the cable information because that may need to change based how far this motor is from the terminal block, right? So for that, what I want to do is create a macro. And you see I got a bunch of macros here already. And with my macro pane highlighted, any group highlighted, I just highlight what I want, okay? And then I just go ahead and drag and drop it to my macros pane. And you see my cursor has that plus sign on it now. And as soon as I let go of it, it gives me the ability to label this. So I can call it LS112 motor, click OK. Excuse me. And now that created that macro, right? Now this macro can be used in any other project, and other users can actually use the same macro too if they added it to their system. To use a macro, all I do is drag and drop it. Just like I drag and drop symbols, left click hold, drag it out and drop it, and I can place it where I want to place it. Happens to be right there. I'll just go ahead and click finish. So when I apply the macro, it automatically increments the tags for the components. So Q2, K2. The terminal strip, it kept the same terminal strip, but increased the number of terminals in that strip. And then the motor also was increased. So M2 is now that motor. So we're gonna need one more here. So we'll go ahead and drag and drop that out and drop that in here. Okay, we'll click finish. And we've got that defined. Now, if I wanted to, I can go ahead and assign my cables for my component by doing an associate cable core. I can come in, do a search, look for my cable. Now in this particular case, I could click new cable, and just like searching my manufacturer's parts library for manufacturer's parts, I can search for my cables. So I can say, I want AWG, American, what gauge do I want? Let's drop down to an 8 gauge. How many conductors do I need? 4 gauge. There's all my 8 gauge 4 conductors in my library. I happen to have a lot of lap in my library. I got a couple of them that I made. In this particular case, I do not want to use a new cable. I have an existing one I want to use, but I'm not seeing that existing one. And that's because my motor is in the wrong location. Okay, so right now my drawing has my location set up to be the main electrical enclosure. I'm not going to put my motor inside that enclosure, right? That motor is going to be out in a different location. So what I'm going to do is use a location outline to define that. So I'll say location outline. And what I'm going to do is just draw a box around my motors. And those are actually going to be out on my conveyor system. They're not going to be in my box, but on the conveyor. So I'll select that. Now it's going to ask me, do I want to change the location of those motors? Yeah, let's change that location. So it changed the location of that motor. So now it is defined out as being in that L2 location. So now if I highlight these and go associate cable cores, I will see that I have 3 cables that were predefined inside this project template for me. And I'm just going to quickly associate the individual wires to those cable cores. Okay, so highlighting both things and just clicking associate does that for me. So we'll get our next one, W2, and get all of that associated also. Okay, I'm going to get our last cable here. And we'll get that all associated. All right. So last thing I need to get in is my power supply, right? Well, happens that I have a macro for that too. So we'll go ahead and drag and drop that in here, line up my wires on that, and place that, and we'll say finish. Now, the cool thing about the macros is it does contain the circuit information, right? So it contains the wires, it contains the symbols for the manufacturer part that you're using, and the manufacturer's part, right? So this power supply brought in that manufacturer's part with that macro. And it includes wire numbers also. So if you have wires pre-numbered inside your macros, it will do that. Now, if I did create my macro with my cable information ahead of time, it would have brought that in also. Okay. So as you can see, within a few minutes, really like 15 minutes, so about a third of the time, I was able to create this. Now, the only thing I don't have on here is my off-page designators. The reason being is I want to go ahead and draw my next system, my control system. So we'll go ahead and get that drawn up before we do our off-page designators. So we're going to come in and grab our 24 volt AC. We're going 18 gauge here. And I'm just going to simply draw out a ladder really quick. Here, I'm not going to worry about my wire styles though. I'm just going to go ahead and draw this out, get this thrown out there as far as some sort of idea of what I'm going to do. And we'll get this all defined. Okay, so we got that drawn out. Once again, come over to our symbols palette, and then we're going to go to our commands. Everything I'm going to use on this drawing is going to be within my commands here. So we're going to start out with a few things here. First, our normally open push button. We'll drag and drop that and place that. Click OK. Once again, it's going to automatically tag things for us. Our e-stop button. Helps if I actually click on it before I try to drag and drop it. There we go. Click OK. Relay coil. We'll go ahead and drop that in here. Okay. And then we've got a normally open contact set. Now, if you guys aren't aware, we do have all of the Ansi and IEC symbol sets available out of the box. All right, so there's a large number of symbols available for you, not just what's here, but if you come up to insert symbol up here, you get the whole ability to search the whole library, which there is a huge number of symbols in there. So if I go any class, you know, I've got basically 2,383 different symbols in here. Okay, that's a gamut of stuff. And you can also import your own symbols. So if you do have symbols from another device, another system that you're currently using that you have custom built for yourself, you can import DWGs. All right, and I know Visio can export to DWG, DraftSight is DWGs, and AutoCAD is DWGs. Right, so it makes it easy to import. And then all you have to do is add the intelligence, which is the circuit information and the attributes, and you're good to go. Okay, so let's go ahead and assign manufacturer's parts. So our normally open push button, we'll go ahead and search for that. Now, I forgot to narrow down my manufacturers first. So let's go ahead and get our manufacturer narrowed down. And this one happens to be a push button with a light built into it. So we'll select that one. And then our e-stop, we'll search for that right there. It's our e-stop. And then the other three devices technically are already on my system, right? This contactor relay actually needs to be my contactor relay from here. So I need it to be 02K1. So we'll get that associated really quick. All I have to do is right click and say assign component. And then what it's going to let me do is I can say, give me the same base class components, which is all the contactor relays. I want that to be 02K1. All right, brought that in. If you notice, it brought in the cross-reference information for me. So it automatically did the cross-referencing also, telling me I've got 14 and 15 available. Oh, that's actually kind of handy because I got one over here, right? That one actually needs to be that same one. So we'll make it same base class, 02K1, assign that. So those two are assigned. Now, the last thing is our indicator light. Well, this technically is going to be our switch. So 03S1 is actually what we want it to be. So that's that switch there. So quickly and easily, I created those connectivity between everything. This got updated with that last circuit being used. So it took care of that all automatically for me. I do need to fix my wire style here, right? Coming out of our coil and our light, we need to have that as a neutral or ground wire. So wire style, replace. And I can say propagate to the equipotential, which basically means everything on this side of those components. Now select what I want that to be. I want that to be my ground here. So we'll select that. And that updates that for me. So quickly and easily, I can make those, just get the idea out there and then finalize the design as I need fit to do that. All right. So we need to connect up our ladder here, right? So from our schematic, we'll go to our origin destination manager. Go ahead and open that up. Now default, it puts them on top of each other, makes it a little hard to see. Ooh, that expanded across all my monitors. Didn't want to do that. All right, we'll bring that back down. Come on. And we want it to just be here. There we go. And then we'll tile vertically. It makes it a little easier to see. So on our origin destination manager, I'm going to use a single insertion here. Allows me to select a single wire, and it will only let me select wires that are not connected to anything. So from our power page, I can select my 24 volt 18 gauge, and I can come over to my controls page, and it's only going to let me select that same wire style. I cannot select the ground wire, right? So it's helping prevent those cross connections, you know, preventing me from making mistakes. So I got both of those connected up. I'll close that, and it's there for it. Now this is up a little high, so what I want to do is go ahead and move things around. So, not location outline, we'll use my stretch command. I'm just going to bring this down just a little bit, so that way it's in my drawing. Okay. So now these origin destination arrows are hyperlinks. So if I double click on that, it takes me to where that was from. So 03-1, double click, takes me back and forth. So that is nice and neat inside the application, makes it easy to navigate, right? So everything's updated there. Now there's a couple other devices that we want to get in here. So I'll go back over to my macros, and I've got a command. So this is a little IO device. So we'll go ahead and drop that in here. Click finish. It's a little digital input output device. I'm going to move it over a little bit. Just kind of stretch that over, keep that there. And then I've got some pneumatic devices that I want to drop in. And I've got a pretty complex pneumatic device here that I want to drop in. And this is just to show you guys that you can do all sorts of connectivity and get stuff dropped in there with that. All right, so this is a pneumatic solenoid, bunch of pneumatic cylinders. So you can do pneumatics and hydraulics also, just so you're aware of it. Here's the coils for those pneumatic solenoids. And then I just have to connect up my ground wires and get those all connected up and together. You know, so if I come up, draw across everything, and now all of my ground wires are connected up. Okay, so those are all connected. Everything's there. If you notice, I brought in 2 terminal strips also here. So I brought that into it. So if I need to add more terminal strips, I definitely can. If we come back over to our project and look at our design rules, check, see if there's anything, and just those are the only parts that are missing. So my X4 and my X5 are missing manufacturer's parts because I didn't include them with this when I created that macro. So I can go to that, edit that terminal strip drawing real quickly, easily. Manufacturer part, assign. So we're going to use our Wago 1201. We'll assign that. And then assign our other one here also. Okay. Get all that assigned. So in about the same amount of time, actually about 2/3 of the time it took me to do the one diagram or the one schematic of just the power, I did the power and the controls all at the same time. Now, if you think about it, what's the other major time-consuming activity that we do as our designs? Our reports. So our drawing lists, our bill of materials, automatically created for us. Our list of wires, automatically created for us. Now, the other thing too is I didn't number half my wires, right? So I'm missing wire numbers for everything. Process, number due wires. A click of a button, I can get all my wires renumbered. Okay, and get everything moved around, numbered, even numbered some of my pneumatic wires over here for me that weren't numbered ahead of time. My power page, numbered all that for me, my ground, my neutrals, all my lines. Now I'm using equipotential wire numbering, so it's giving me wire numbers of the same potential. So if I wanted to show all my wire numbers at once, I could definitely do that by going into my wire styles and display what do I want, equipotential marks, and turn them on or off. If I want wire numbering, I can turn on individual wire numbering and do all that and have that availability there for me. All right, so let's take a look at our reports though. Now let's take, we say we need our drawing list, we need our bill of materials, and we need our list of wires by line style. All right, so we need all of those. So we'll generate drawings of all of them. So get all that created, get those. Now, if you notice, I've got some other reports here, such as my tagging. So if I do have a label maker that needs to create all my labels for me, such as a Brady, wire labeler, I can export all of my labels to an Excel spreadsheet and bring them into that software and generate them, right? So list of wires with origin destination tags, list of wire tags, so if I just need the wire numbers, and then the quantity is there for me. Terminal strip tags, component tagging, cable tags, then a list of all the tags that I would need. So you've got a bunch of abilities there. And these are just SQL reports. So if you need to customize anything, you can definitely have the ability to do some customization to that as far as what is pulled into that report. So here's our typical drawing list. Now it doesn't have the rest of our drawings, right? So I can quickly and easily do that, update report drawing. Reason it didn't add them is because it created the drawing list first before it created everything else, right? So we've got that. Now that's updated with everything else. Bill of materials grouped by manufacturer. So everything's grouped by the manufacturer. I've got some automation direct stuff, which is my pneumatic stuff I brought in, my Leroy Sumner motors, my SolidWorks stuff, and then all my Wago terminals. All right. My list of wires by line style, origin and destination information, the wire number, broken up by gauge and color, or broken up by wire styles is what those are. So all that's created there for me. Now, there's another set of drawings that we can do. Let me go ahead and just minimize all this. And that's from our process tab, is we can do a 2D cabinet layout, right? So I'm just going to take and create one from the main electrical enclosure. So without leaving the schematic environment, I can start doing a layout drawing of this cabinet, okay? And probably the first thing I need to do to get my cabinet in there, right? I don't have any place to put this. So by going into my location properties, I can actually add components to this. So if I come in and say I want to add a box or cabinet, so we'll get that. So I'm going to grab an enclosure, and this one's going to be a Rittal enclosure, and it's got 1055 in the name. Oh, there's the enclosure. Oh, there's the mounting plate. So we'll go ahead and grab both of those and select those and put those in. All right. Oh, that added it to the location. That's not what I wanted to do. Yes, I actually wanted to come in and go to the properties of this. I added a location. I didn't want to do that, so I was misclicked there. So we'll get those added again. Select that. Okay. And those show up in my tree here as needing to be inserted, right? So there's the enclosure. So we can insert as cabinet. And I can place that over here. Let's actually place it right about there. Now this is a scaled drawing, so I can change my scales here. So I'm going to go 1 to 5 on my scale, and that adjusts the scale of that enclosure. So I'll drag it over just a little bit, clean it up, and then we'll get my mounting plate inserted also. Now these are actual symbols from the manufacturer. So these are DWGs that we got from Rittal that gives us the ability to bring in what their cabinets actually look like. Now before I mount my components, I would need something to mount them on. So we'll add a DIN rail here. And I'm just going to come in here and look for I'm going to go all. And in this case, I'm going to go to my library. And I've got a demo library here. So you can actually filter out your components based off libraries. So you can create basically a library of approved components to find. So we'll grab that one and insert it. Now when I place this, it's going to place it there. If I need to adjust the size of it, I can come up and adjust length of DIN rail or wire duct. And then I can put in a specific length, such as 22.5 inches here, and add that. Now the cool thing about this is, because this is a symbol, if I need more of them, I can copy it, right? So I can do copy, and then I can do paste. And then I can actually add that in as an additional part, and it fills out my bill of materials. So if I paste one more time, it's going to give me 3 of those DIN rails. Now I can go ahead and place my components, such as my fuse disconnect. So I can right click insert. It's going to go grab the associated symbol for that part. Okay, the 2D footprint symbol for that part. I can assign or insert multiples at the same time also. So here's all my circuit breakers. I can insert those, and it gives me spacing up here. So I can say, you know what, I need these to be a 1/2 inch spacing, and place those. And it gives me a 1/2 inch spacing between the components. Now, it's hard to tell what's already inserted and what's not inserted. So I'm going to say hide already inserted components. So let me turn that on really quick, and I'll click off and click back on to clean that up. So we've got our power supply that needs to be inserted, our little IO device. So we can actually get all of those at the same time also. Insert those. And we're going to say we're going to put the power supply first, our relays, and then our little PLC. So we'll insert our power supply here first, and there's all of our other devices. And then inside of our cabinet, the last thing to insert is our terminal strip. So we'll insert terminal strip, and we'll place that down here, and that's our terminal strip inserted. And then our 2 buttons or switches, right? So our start button and our e-stop. Now, if I needed to add dimensions, I can definitely do that by coming up here, say linear dimension, and I can say, you know, I can turn on my object snap, and I can say, you know what, from the, you know, let's turn off regular snap, and let's turn on our endpoint and our center. So from our edge of our cabinet to the center, we can say that's 519. You know, so we can actually dimension this out, so that way our shop floor knows where those specific dimensions need to be. All right, so I can place those and bring those down. So we can get all that placed where we want it, add our dimensions that we need to. You know, we can add via our modifier, our draw, we can add text and all that information that we need and set that stuff out and define that. Okay, so all of our components are in there now, all of that. Now it is another drawing type. Now we may want to reorganize our drawings. So we got our cover page, and then our drawing list, and then our power and our control. Well, maybe we want our layout in front of all of our reports also. And maybe the other thing we want to do is add a folder, so we can do this and make it for our reports. Click OK. And then I can actually take all of our reports and put those in that folder to help organize things, right? Now, last thing we want to do is renumber our documents. So we'll update the marks. We'll tell it to recalculate everything also. Click OK. Yep. So now our drawings go 0, 1, 0, 2, 4, 5, 6, 7, 8, 11. So it goes in order. So we'll update our report drawing for our drawing list. So that way it gets the updated information. All right, so we look at that. Now those information is correct. Ooh, but I caused a problem, didn't I? All of my components are based off the drawing they're on, and that's not correct anymore because that was 0, 2, that's 0, 3. But you know what? Really quick and easy, I can renumber marks, tell it to recalculate everything, click OK, and it's going to go through and redo everything for me. So all that becomes 0, 3 now. And then we can tell it to renumber our wires also and recalculate based off their information. So quickly and easily I can make those changes without having to go back and redo everything. Okay, so that is pretty much our drawings, our reports, everything done real time, and even our list of wires will have to be updated. But like I said, update report drawings, and it will go through and update all of that for us. We're not having to go open up Excel, not having to go fix all of that and do a find and replace on everything. So the design changes happen a lot faster for us in that instances with everything. Okay. Now I can, if I needed to, I can export my drawing package to DWGs or PDFs if I needed to. Okay. So that's kind of the basics of our, so we took a look at that really quick, and realistically what I did was did our faster schematic creation with fewer errors, right? So what did we use? We used intelligent drawing tools. So specific wire styles, excuse me, specific wire drawing tools. I was able to use a search functionality to find the symbols or use my quick drop pane over there also. We automatically device tagged and wire numbered, automatic reporting and error checking, right? So we did all that within it. So all of this information is there for us with our design rule checks, component information, and our searching. I showed you data reuse and new content setup. So kind of I didn't show you guys the copy and paste, but it works the same way as the macros. I did show you the copy and paste on the DIN rails. Works the exact same way for circuit information also. So if you copy and paste wires and symbols, it does exactly the same thing. Set up a macro and use that for you. I didn't show you a black box creation, but we do have black box for setting up new symbols and new components as you needed to, if you needed to, update black box, insert in that information. Okay, rapid change, right? So we updated all our reports there for us, handled the change between everything, documentation layout, moved things around, and high output, right? So we can do those PDFs, those DWGs that our customers may request of us. All right. So let's kind of look at what we did and went through, some of the items that need to be updated and fixed and redone based off other changes. So to wrap it up, so we did a fast creation with few errors, data reuse and new content setup, rapid change management, and then professional, accurate final documentation, right? So there's an example of the final documentation that you can get out. Now, one of the drawings I didn't show you guys was our terminal strip drawings, and you kind of saw it pop through there on the side over here. Well, that kept track of all of that for us and created that. So if we look at the statistics that we did, right? So typical drawings pages created by users. So there's 3 of them that I created, right? our power, our control, and then our layout. 56 components, 17 unique, 56 wires, 3 unique wire styles, 30 cable cores or 12 cables. If I did everything, I didn't quite do everything in there for you guys, but drawing pages created automatically, 3. I didn't show those, but we could have done that. Created. Reports created automatically, 9. Intelligent attributes displayed. All that attributes and fields were updated automatically for us, right? So a lot of information, a lot of detail there. About 40 minutes. That's about what it came in under, right? As you can see, it took me 40 minutes alone to draw the power page inside of DraftSight. So it's showing you guys the ability, the time savings, the automatic checking, all of that is attributed for saving that information, that time for you. All right, so with that, that concludes. Actually, before I get into this, is there any questions? I know I didn't give you guys much time to ask questions during the demonstration. If you do have a question, there is a questions pane. Go ahead and enter it there. We'll stick around and I'll answer those questions as they do pop up. If you guys aren't aware, we are doing our Mechatronics series. Coming up next week is our PCB with the PCB connector. So using SOLIDWORKS PCB and using the SOLIDWORKS PCB connector to get your actual PCB layout into your SOLIDWORKS assemblies. All right. If you guys aren't aware of that, there's another, Hawkridge Company events. Get you right there with that information too. Okay. And also, we are running a promo right now. In fact, SOLIDWORKS is running a promo for the rest of this quarter, so it expires at the end of the month. Basically, if you buy SOLIDWORKS Electrical or SOLIDWORKS PCB, you can get 50% off any other product that you buy at this time. So if you need another seat of SOLIDWORKS Mechanical, great time to take advantage of this promo. If you need simulation, great time. Even flow simulation, right? So especially if you're doing anything with PCBs or electrical and you need to see how your airflow goes around everything, great time to take advantage of all of that. Once again, if you guys are around, have any questions, we'll be here. And thank you for attending today's webinar. This will be recorded and will be posted to our YouTube channel in the coming days. Thank you.